We present Plan2Scene, digital 3D representations of interiors have a variety of applications, such as virtual walkthroughs of real estate listings, previews of products placed in a room, and training AI agents in 3D simulators. These 3D scenes are usually created through intensive manual design, or imperfectly captured using depth sensors and 3D reconstruction techniques. Neither of these approaches are readily usable by inexperienced users. However, real estate websites often provide floor plans and associated photos of residences. Prior work has used precise camera view estimation to project these photos onto walls. But this approach cannot handle surfaces not seen by photos, and objects such as furniture are unrealistically projected onto walls. Our work addresses these limitations. We introduce the new task of Plan2Scene, converting floor plans and photos of a residence to a textured 3D mesh of a house. Given a floor plan image and the photos of a house as input, a floor plan vectorization approach detects walls, doors, windows, room types, and fixtures from the floor plan. We lift the vectorized floor plan into 3D using a rule-based approach, and place CAD models for fixed objects in the floor plan. The photos of the house are assigned to the rooms. Then we detect surfaces in photos and rectify them. Next, we extract crops from these rectified surfaces. We condition an embedding-based texture synthesis approach on these rectified surface crops to synthesize a texture crop for each photo observed surface, which can be tiled and applied as a texture. We use a textureness score based on VGG statistics to determine the best surface crop for texture synthesis. Next, using a graph neural network, we leverage inter-room and intra-room consistency priors to generate tileable texture crops for unobserved surfaces. The final output is a textured 3D mesh model of a house. In this paper, we focus on texture generation and propagation, and assume other steps are given or handle them with simple approaches. The key challenge in the Plan2Scene task is to operationalize what constitutes a good texture output. A good texture should capture the substance, color, and pattern of the surface. In addition, the texture should be tileable. Using our approach, we can generate textures that captures the four properties and corrects for illumination and other artifacts in the crops. Let's look at our results. Our approach textures observed and unobserved surfaces, plausibly texturing the entire house. We conducted a user study, asking users to choose the best in an hours versus baseline post-choice setup. We compared against three baselines: a texture retrieval-based approach, the direct use of a crop sampled from a surface, and a naive application of neural texture synthesis. Our method was preferred over each baseline about 70% of the time. Thank you for watching.